Australia's steady flow of mineral wealth has turned into a gusher. The unprecedented mining boom has produced a demand for new ideas, new areas for exploration, new techniques to persuade the reluctant earth to give up its hidden fortunes. On the east and west fringes of the vast island continent, the beach miners are sifting a fortune in heavy minerals from the deep sand. The richest of these, rutile, is refined into titanium metal. Australia exports 80% of the world's rutile to a growing market already undersupplied. Future demand for rutile seems certain to move far ahead of supply. Yet on present estimates, it will be only a matter of 20 years before Australia's onshore deposits run out. Where else can the miners turn for new deposits to satisfy present demand and ensure long-term future supplies? Some say the answer lies out to sea. The search for offshore mineral sands was begun in 1966 by an Australian company, Planet Metals Limited. Working alone in an entirely new field, Planet had to pioneer new techniques to explore the beaches beneath the sea. Previously accepted navigation methods were not good enough for accurately plotting offshore rutile deposits. The breakthrough came when Planet started using a complex scientific device powered by a simple portable generator. A laser device designed by an Australian electronics expert in association with Planet.
Jason, you would have about 1 boat length to go now, mate.
The laser beams out a perfectly straight and narrow shaft of pure red light. The beam can be seen as far as 8 miles offshore in broad daylight. Aimed in a direction precisely fixed by surveyors' pegs, the laser beam is visible to the helmsman aboard the ship only when the vessel is dead on course. Now the ship's course can be plotted accurately, while electronic charts are made of the sediment and rock layers below the sea floor. A chain of 36 hydrophones in an oil-filled pipe is trailed behind the ship to pick up the echoes of signals sent down by the sparker. Later, the charts produced will be interpreted to decide where to drill. Acoustic signals bouncing off the varying density layers of sediment and rock below the sea floor are picked up by the hydrophones and relayed to a sonic recorder, which draws a chart of the ocean subfloor. The process is called sub-bottom profiling. Information vital to the geologist is recorded here. The operation is summed up by the General Manager of Planet Management and Research, Mr. Graham Brown.
The sub-bottom profile charts are sent to the Sydney office, where they are interpreted by geologists and geophysicists. This particular chart shows the water level on the top of the chart. This is the sea floor, and the bottom line here is the bedrock with the sand column overlying the bedrock. It also indicates where an old beach line was formed 37,000 years ago, and this is our target for locating rutile and zircon deposits. Once the interpretation is complete, the positions of the beach line are plotted on maps, and from this the geologists determine where the drill holes will be located. The ship then returns to sea, and the lasers are set up on the shoreline to locate accurately the positions of the drill holes so that the drill may try to locate the rutile and zircon deposits.
Now, moving midships, that's looking quite good. North 10, Jay.
Roger.
South 5, and you will be right on line.
Roger.
Yes, that's looking quite good. Right on line there.
Roger.
Once again, the laser ensures that the ship is on course. The beam virtually disappears if the ship strays only a foot or two off course. When the required position for drilling is reached, the spot is marked. To steady the ship for drilling, 2 stern lines are also run out. Final adjustments can be made to the vessel's position by pulling up or letting out any of the 3 anchor lines. A final check on the position and a stabilizer is lowered to minimize the ship's rolling motion during drilling. The laser has made it possible to position the ship many times more accurately than with previously available navigational methods. Now it's possible to anchor the vessel within 10 to 20 feet of the exact position required for drilling. The search for offshore mineral sands extends over 3,500 square miles off northern New South Wales and southern Queensland. Drilling has reached down to 40 feet below the seafloor. Compressed air pumped to the drill stem forces the samples to the surface. The submerged beach lines have been fed for centuries past by sand and minerals eroded from the onshore mountains, the Great Dividing Range, and washed down to the sea along 7 major river systems. The sea level here has fluctuated over the centuries, and the processes which formed the undersea beaches are thought to be the same as those which produce the present shoreline beaches. To the uninitiated, it's just a handful of sand and shell grit, but it also contains a workable percentage of rutile and zircon. The precise origin of samples taken from below the seafloor is carefully documented. Accurate navigation made possible by the laser beam will enable the ship to return to the exact location of any one of the thousands of samples taken. But first, the samples must undergo careful analysis at the Sydney laboratories of Planet Management and Research. Samples arriving at the laboratory are put through a splitter to get a small, representative portion for careful examination. This is a simple but critical operation. The small amount of material to be tested must accurately represent the entire sample taken from the ocean bed. The representative sample is washed to remove the clay so the sand grains may be easily separated. The sample is then dried under an infrared lamp. A known quantity of sample is poured into heavy liquid to separate the heavy minerals from the sand. The lighter quartz and feldspar go to the surface, the heavier rutile and zircon go to the bottom, together with other heavy minerals like ilmenite and leucoxene. Now the heavy mineral concentrate can be collected for some of the many processes ahead. With great care, a portion of heavy mineral concentrate is prepared for examination under the microscope. Under the microscope, a heavy mineral concentrate with zircons predominant, showing their characteristic crystal forms. The rounded corners of each crystal tell the scientist how much wear and tear the mineral has undergone during its journey to the undersea beach line, giving some clue to its origin. By contrast, rutile varies from almost opaque to deep red. A good idea of the value of the sample can be obtained by microscopic examination, but these studies are supplemented by X-ray and infrared examination. Another sample is placed in the magnetic separator to separate the slightly magnetic rutile from the non-magnetic zircon. This is a simple illustration of the separator at work. In practice, it enables the geologist to separate pure samples of rutile and zircon from the heavy mineral concentrate. Another sample of heavy mineral concentrate is prepared for the crusher. It's the first of a number of steps leading up to infrared tests to determine the amounts of rutile and zircon present. The crushed powder is weighed carefully. It's then put through another grinding and blending process before it's finally loaded into a machine to be subjected to intense pressure. Thanks to careful preparation, the tiny disc will reveal the percentage of rutile and zircon present in the original sample. The disc is placed in a spectrophotometer, where the amount of rutile and zircon present is measured by a process of infrared absorption. The graph tells the geologist what he wants to know about the original sample taken from the sea nearly 1,000 miles away. An X-ray diffraction machine is used also to determine the mineral composition of specially mounted concentrates. Patterns characteristic of rutile and zircon are drawn as an X-ray beam scans the sample. Progress results of the exhaustive studies are reported regularly by the head of Planet's laboratory, Dr. John Reed, to the chairman of the Planet Group of companies, Mr. John Fuller. Mr. Fuller says that results of the offshore work so far have been encouraging. He believes that enough reserves will be proven to establish a large-scale mining operation. New techniques in the laboratory and at sea have established Planet as an authority on offshore rutile exploration. Thanks to the laser navigation system, the work of drilling and charting the ocean bed can go on day and night. Inspired by the success of its exploration program, Planet intends to continue its pioneering search for rutile and zircon, vital to the world's expanding technology.